Arrays are very useful, but they are sometimes a difficult concept for students to implement when it's time to solve a problem. So in this video, we will take a look at one of the unassigned problems from the textbook and walk through a solution. As always, two things to know about this kind of a video. The first is that it's not as useful if you just watch it and don't participate. So stop the video and take a shot at it before you see my solution. The other is that I don't plan my solution ahead of time because I like for you to see the way I think through the solution. And sometimes I make mistakes along the way, and that is fine for you to see. I don't edit them out. So in this problem, we're going to create an array of 10 integers, and then we're going to prompt the user with a simple user interface. They can choose to view the integers in their regular order, which is not necessarily numeric order, just whatever order they are in. They can view the list in reverse order from the last to the first, or they can choose a specific element out of that array to view. So stop the video at this point and make your own attempt. And when you're finished or when you get stuck, come back and play the rest of the video. So I have created the project I'm going to use for this solution. I have my heading block at the top here started out. And as always, it's a good idea to start with some test cases. Now the test cases here are maybe a little bit different. The problem isn't asking us to get these numbers from any specific place. The user doesn't have to input them. We just need to have some numbers. So I'm going to make up a list, essentially at random here from the top of my head, of 10 integers. It doesn't give me any other guidelines. So I'm just going to say that I need 10 integers here. The only thing I'm thinking about is making sure that the numbers are not in any kind of order. So I've got 1, 2, 3, 4, 5, 6, 7, 8, two more. So I will use that as my list of numbers to put inside of an array. And now my test cases are really going to be what is the output based on the choices the user makes in our user interface. So if they choose to display in order, then they're going to get the exact same list, right? If they choose to output in reverse order, then they're going to get the same numbers but in reverse order. And if they choose a specific position, let's say they choose position 3, then we're going to get the number that is the integer that is in the position subscript 3. So remember that we start with 0, so 0, 1, 2, 3. So the number in position 3 is negative 23. And I'm not going to write 10 test cases to test every possible option here, but I do want to have at least a couple that I can verify. So 0, 1, 2, 3, 4, 5, 6, 7, 8 should return 65. So I'm going to use something like this for my test cases, and the truth is with test cases, some types of problems are more difficult to organize testing than others. And what I really want to see is that you are making a concerted, intentional effort to test your code, that you're not just writing code and submitting it with whatever it happens to do. So as I think through a solution to this and plan ahead how I'm going to solve this, I think I'm going to essentially declare my variables, which is primarily the array. I'll need a user interface loop that's going to keep kind of prompting them for their choices. And then within that, I'm going to have my three choices here. Display in order. I'll indent this to show how that's going to fall under the user interface part. Display reverse order. Then I will prompt for and display individual element. So those are the tasks I have to accomplish with my code here, just in a very abstract sense. And I'm going to start off by creating my array. I've already decided what my list of numbers is going to be, my 10 integers. So in this case, the numbers are just numbers. I'm a big believer in having descriptive variable identifiers here. In this case, there's not a lot I can do with that. If the numbers had some significance, they were, the ages of people or something like that, I would want a better name. But now, as hopefully you know by now, there are two ways to get my data into this array. I will start to show you the longer and sort of, I guess you'd say, traditional way of doing this. I'm going to just declare my array, and I'm going to say that I want a length of 10. I want 10 elements, and all of those are going to get initialized to default values. In the case of integers, they will get initialized to 0. And if I want to put data in, I can just do that one at a time using the subscript. So in subscript 0, I want 45. In subscript 1, I want 62, and this is perfectly fine, and there is absolutely nothing wrong with doing that, using that approach. As you can imagine, it takes a little bit of typing, right? I have to have 10 lines of code, and the bigger my array is, the more I'm going to need to type. So this is where we can use this idea of an initializer list. And so an initializer list, you can only use this when you first create your array, remember? So I'm just going to do something like that. That's my initial setup for my numbers, and the rest of this now is going to come down to working with the array within my user interface. And I think the last thing I'm going to do is kind of the loop, maybe not the last thing, but I would like to know that my array is set up correctly. And with an array, the way I do that is I traverse the array, meaning I move through the array in order from the beginning to the end, and I output it. Well, that's one of the tasks that I am required to do for this problem anyway. So I'm just going to kind of skip to that part, and I'm going to write a loop that will iterate through the array and output all of the values within it. And so the term that I always use for this is a traversal. An array traversal is an algorithm, a loop essentially, that starts at the beginning, it goes through to the end. The term I use is that it touches every element along the way. In this case, it touches every element by retrieving it and outputting it. But it could do anything. We could sum all the values or something like that. And there is a mechanism in C# called a for each loop that is very, very useful for this. I consider it kind of optional, so I'm not going to show it here, but just know that it's a very useful tool, and one that I would use if I were programming sort of in my life away from teaching. I would probably use a for each loop for this. But this is also good because it's good practice writing loops, which are still probably kind of new to us. Now, in our traversal loop, you will often see I as the identifier for our variable, and I had just talked about how I'm a big believer in variable names being descriptive. I is short for index, and so it's going to refer to the index of each element in turn. And so this is a pretty standard programming convention. You see I used very often. And this traversal is used so often that eventually you'll just have this as almost a pattern in the back of your mind, because so much of what you do with loops is revolves around using a traversal. So you'll eventually memorize this, and if you look at any examples working with loops, if you look things up online, you'll see this just constantly. So this is going to, remember, arrays are indexed from 0 to the length minus 1. 0 is the first index. The last index that's valid in an array is the length of the array minus 1. So if I have 10 elements, then I go from 0 to 9. And so that's what this loop does. I start at 0. I keep going as long as I is less than the length. So that means it's going to go up to and including 9 if the length is 10. And it's going to go up by 1 every time, and you do often see the prefix version of that. It doesn't matter in this case. And the key with a traversal, it starts at the beginning, it ends at the end, as dumb as this sounds, and it doesn't miss any along the way. So it's the term I would use is that it's bounded correctly, and it doesn't skip anything along the way. And so I'm just going to say console.write, and I'm just to make a simple test here, I'm just going to output numbers at position I, subscript I, and then I'll tab over just to make the output a little more readable for the user. And then after the traversal is finished, I'll just add a new line onto there. Okay. Now I've got, I'm going to add my read line at the end so that my window stops when I'm done. My window stays open. So here's my output. It looks pretty good, right? I start at 45, I go all the way through to 5. That's the order that I had originally set up my list. So that part of the problem is actually finished now. I don't have any user interface set up to kind of choose. But again, this is that idea of a traversal. Okay, a traversal. And so this traversal just goes through in order and outputs every element. If I understand how this traversal works, displaying the array in reverse order is actually the same thing. It's just that my traversal is going to start at the last element. It's going to move backwards and end when I get to the first element. And so it's really just a modification of this traversal that I've already created. And I'm going to go ahead and implement that now, again, without any particular user interface set up for this. So now I'm going to create an index integer here, and instead of starting it at 0, I want to start it at the very last index. So I'll start it off like this, and I pause here because maybe something has triggered in the back of your brain that that's not exactly right. Numbers.length in my case is equal to 10. All right, and I don't want to start at 10. That's not a valid index. I need to start at the length minus 1. Okay, and then I want to repeat as long as I is greater than or equal to 0. And then instead of adding 1 every iteration, I want to subtract 1. And then after it's done, I'll go ahead and add a little line feed, a new line at the end of that. So let's run this and see how it looks. And there's my output. You can see the first line is my original traversal in order. The second line is my reverse traversal, so to speak, where I start at the last index and I subtract one each time. So that is looking good so far. What I want to point out here about this idea of a traversal is that I am using this length property to help me set it up. It would work fine if I just put in the number 10 because I know that there are only 10 numbers in there. The problem is set up and tells me to only put 10 numbers in there. But if I get in the habit right away of bounding my traversals with the length property, then my code still works no matter how big the array is. And so I can come up here and I can just tack a few more numbers on, and my code doesn't break and it doesn't miss any data. So that's not required by this problem, but it's a really important habit to get into as you're learning to work with arrays. And the same thing applies here. Instead of just saying int I equals 9, I'm going to use the length minus 1 to refer to that. So I had started out this little chunk of code by just saying, well, I want to be able to test and make sure that my array was created correctly. And then it was pretty logical from there to reverse it. And so I've ended up with a pretty good chunk of this problem already solved now. I've got my display in order code block. I've got my display in reverse order code block. And the only piece left in terms of the basic functionality is letting the user display an individual element. So before I get to that last piece, I think it's a good time to start with some of the user interface. And so I'm going to create the prompt for the user. And at first, my first iteration of this, so to speak, is going to be just it runs one time. It lets them choose which of these three options they want. And then the program stops. And then after I've made sure that's working, I'll add the idea of a loop. And to save time, I'll pause the video while I do some of this typing. Okay, so I've just created a fairly simple little prompt. I've got 4 choices, and I'm going to use integers for user input. So the user will just type in 1, 2, 3, or 4. 4 will be to exit. And in order to get this working, I'm going to need some additional variables here, and as always there are different ways to do this. So I'm going to start off with I'll get the input as a string, and I like to just assign it to an empty string to start with, and then I'm going to have I'm going to convert that into an integer that represents their choice. And again, I like to start that off with a default value there. And I will get that input from the user. And then I'll need to do a conversion. So I'll say choice equals .to int 32 is fine. And I'll convert that input. And I think I'll go ahead and test this now. It's not going to work correctly yet, but I'll see how it's looking. So there's my user interface. It's sitting there waiting for me to type something in. If I type in 1, no matter what I type in, it's going to run. It's going to print out both of those because I haven't done any branching yet. And then we've got the same old problem that we probably are used to around here, where if the user types in something that can't be converted to an int, we're going to run into some trouble, but that's beyond our scope for today. That's just a limitation we'll have to live with. But I believe so far I'm happy with just the basic user interface. And so now it's just a question of implementing if statements based on what choice they have selected to determine which chunk of code I write. So I will just say if choice is equal to 1, then we're going to display in order. If choice is equal to 2, I will display in reverse order. If choice is equal to 3, I'm going to need to add some user interface here, right? I'm going to need to prompt them for which they would like to display, which I haven't done yet. And if their choice is 4, the program is going to stop running. We can kind of address that when we start looping, but let's see what we've got here. So if I press 1, I get the numbers in order. If I run it again and press 2, I should get the numbers in reverse order. If I run it again and press anything other than those two choices, right, I'm going to get essentially nothing. There we go. At this point, I can either work on this choice number 3, prompting an individual element, or I can get the user interface loop done. It doesn't particularly matter which I choose to do, but I think just to complete my cycle here, I'm going to go ahead and now prompt the user for which element they would like to enter. So I'm going to create a variable. I'm going to prompt the user for some input, like what element they want, and then I'm going to output that element. So I'm going to pause while I type some of this. Okay, so typically I prefer to declare my variables at the top of my main method. But there's no technical reason why I can't create a variable someplace else. In this case, this variable is very specific to this chunk of code, this little code block for choice number 3. So I don't particularly have a problem creating it here. And it honestly, visually, it makes it easier if we can see it here as opposed to putting it up there where I have to scroll up to show it to you. So I've created an index variable. This is going to be what index do we want to look up for the user. I've prompted them, and now I need to get that input. So earlier, I had created a string, retrieved the input, and converted it to an integer. And we might as well see a little shortcut here. I'm going to say that index equals console.readline. Now, that's problematic because readline returns a string and index is an int. I can do the conversion on that readline result directly. So by way of comparison here, this accomplishes essentially the same thing as these two lines of code, right? Instead of putting the variable here, I just get to that read line and put it there directly. So it's just another way of doing it, and it's kind of a common thing to see since programmers like to save themselves typing. So now, in theory, after this, I've got an index number from the user, and so I can output whatever is in that spot, that element in the array. And so I'll just make it say position and whatever they've typed in. And again, just sort of making it look a little bit user-friendly. And here's the important part. How do we retrieve whatever is in that spot? Well, the array is called numbers. For the subscript, we would normally type in whatever literal value. If I want the first one, I'd put 0. If I want the last one, I'd put 9. In this case, I want whatever number they have typed in. So the subscript can be anything that evaluates to an int, right? I haven't tested this yet, so let's see if I've made any mistakes or if this works correctly. I'm going to go directly to 3, choose an element to view. What position would you like? I would like position 3, I believe was one of my test cases. And it says position 3 is negative 23. I'm just going to peek and make sure that is what I expected. Yes. And so I notice I'm not really doing my full test cases yet because my program's not done, but that's good to check along the way. So I think I'm happy with that at the moment. And now I can move on to creating the loop that causes this program to keep running until the user is finished. So I've got this whole big chunk of code that I need to repeat, everything from the start of the user interface down through this last choice that they have as an option. And this is what we would categorize as an indefinite loop. I don't know how many times it's going to need to run because I don't know how long the user is going to keep working with my program. So that's an indefinite loop. I can use any loop structure that I want. I could use a while loop, I could use a do while loop, I could use a for loop. But as we've learned in previous videos and readings, while loops and do while loops lend themselves well to this kind of an indefinite loop. I would not like to use a for loop here. Again, I could do it. I would probably end up using like a break statement, and I'm just not a big fan of that. Aesthetically, I guess you could say. So I'm going to use either a while loop or a do while loop. The difference between the two, remember, is do I want to run the code first and then check my condition? Or do I want to check my condition, which means the code may not run at all, and then jump into the code block? So I want to make sure that my code runs at least once. So that sounds like a do loop to me. So the do loop is going to start there. It's going to come all the way to here. And then my condition is while the user has not chosen for. So while choice is not equal to for. And let's test that and see where we end up. And so I should be able to keep typing 1, keep typing 2. If I try 3 and put in 8, I get 65. And it actually will keep working no matter what I type in, as long as it's a valid number, right? As long as it can be converted to an integer. And then when I hit 4, it should stop. At this point, my program is finished, and all that is left is to go through my test cases, try them all, make sure that my output matches my expectation on these, and then this program is ready to turn in.